Dear students, welcome to the 7th lecture of 8051 timer/counter. So in the 6th lecture we have seen about mode 0 in detail. Now in 7th lecture we'll see about mode 1. Mode 1 is called by the name called 16-bit timer mode. Here since the name is 16-bit, we are using the 8 bits of THX as well as 8 bits of TLX. These two are 8-bit wide, right? As you know, these two are 8-bit wide. So the 8-bit of THX register and 8-bit of TLX register, these two registers are used and these two are cascaded with one another so that it will become a 16-bit timer slash counter mode. Okay, then the diagram for mode 1 looks like this. So it's very simple. It is similar as that of mode 0 except this block. In mode 0 we have taken this block as a 13-bit. Here we need to take the 8 bits of TLX register and 8 bits of THX register so that the combination of these two becomes a 16-bit wide. Okay, so and this process this process is very clear for you all. Once again I will repeat. So if I work with respect to the timer, the pulse is taken with the help of oscillator and divided by 12 circuit, and we have to make C/T bar is equal to 0. And if I take it as a counter mode, then the pulses are taken from pin TX, right? So and there we need to make C/T bar is equal to 1. So after this the next block is the timer/counter block, where 8 bits of TLX and THX are used. The next is TF, that is timer overflow flag. So now we need to start our timer. Okay. Now, so how the timer will start, or how the counter will start, that will start with the help of again this block, right? This block. So the output of this block should be is equal to 1. That means we need to take the two cases as I said in the last lecture. If gate is equal to 0, the output of this is equal to 1, right? Okay, and we need to make the output of this AND gate should be equal to 1 only when a TRX must be equal to 1. And if I take a gate is equal to 1, the output of this is equal to 0, and there we need to make the output of this. The output of this is equal to 1, so that I will get here. So this is 0, this is 1, and here I will get 1, and the value of TRX must be equal to 1. So what is my conclusion is the output of this particular block should be is equal to 1. Then only I can close this switch and our counter or a timer will start. So how it starts means, when this switch is closed, after getting the one value inside this, the timer or a counter will start. Now it starts count. So how it starts? First it will take 0000H, 0001H, 0002H, like that. So the maximum value now it takes is, since it is a 16-bit timer or a counter mode, the maximum value it will take is FFFH. So when this FFFH resets back to 0000H, at that instant automatically TF flag, TFX I will call, TF flag, X stands for 0 or 1, will be set equal to 1. So here I have written one statement that TF goes high whenever FFH tends to 0000H. So when the counter or a timer reaches the maximum value and when it resets back to 0000H, automatically the value of TF will be equal to 1. So the programmer will come to know that whether the counter has been reached to 0000H. If it is equal to 0, then the programmer will come to know that still the timer or a counter is in running mode. Okay, so this is about 16-bit timer or counter mode. So the next part is how we can program this. The programming is similar as that of mode 0. Again, we need to calculate the value of t mod. So how the value of t mod is calculated? If I am using timer 0 or a timer 1, and here compulsory we need to take the mode 1, right? So put these values inside a t mod register. First we should tell to the programmer that which timer is to be used and in which mode we are working. That is the first step, right? Second step, we should load the value of THX, TLX. So we should load the value of THX and TLX with initial count value, right? So the next is third step. Third step is to start the timer. We should start the timer. So how we should start the timer? We should start the timer with this particular bit, right? In order to start the timer, which instruction is to be used? Set B, single bit is to be set. Set B TRX. X stands for 0 or 1. If I am using timer 0, the value of TR0 is to be taken. If I am using timer 1, the value of TR1 is to be taken, and that has to be set. That means we have to start the timer. Now the fourth step, in the third step we have started the timer. Then how the programmer will come to know that the timer is running or whether it is stopped? That is by monitoring. Monitoring the value of TFX, right? That is by monitoring the value of TFX. If it is equal to 1, then it has to come out of the loop. If it is equal to 0, right? If it is equal to 0, then still the timer or a counter is in running mode. So that has to be written with the help of the instruction. As I said in the mode 0, JNB, that particular bit, that is TFX, comma the label, right? So the label is given with the same instruction here like this. So this particular bit is to be monitored continuously until the value of TFX will become equal to 1. When it becomes equal to 1, it will come out of that particular loop. Then what is the fifth step? After when it resets back, we need to stop the timer. So how the timer is to be stopped? With the help of CLR bit. So CLR, that particular bit, right? So next sixth step. In a sixth step, what is to be done? If I want to reload, if I want to restart this particular mode 1 operation, we need to clear TF, right? We need to clear TF flag, right? This is the first step that we need to do. If I want to start for the next round, we need to clear the value of TF. Next, seventh, we need to repeat the step. We need to go back to the step. We need to go back to the step 2. What is step 2? The step 2 is load THX and TLX once again, and the process has to be carried out how many times we need, right? So this is the programming steps of mode 1. Hope this is clear. If you have any questions, you can put the comments. I will try to answer those questions. Thank you.